screen now. If you're not, just let me know in chat. But you should be seeing the screen. I just want to remind you to watch this schedule and keep track of things. Today we're supposed to be looking at 6.4. We're still looking at 6.3, so we'll catch that up over the next few days. But this is the plan for when you should start the sections, all right? As well as the quizzes and tests. So right now, if you look in my stat lab, you will see if you look in my stat lab, you will see you've got some assignments going right now, right? And there are due dates on those, I guess, right here, right? But you'll see 6.2 and 6.3, quiz 5. The practice, the chapter 5, 4 and 5 test is due in a couple days, right? We extended the deadline on that, so you have lots of extra time on that. So anyway, just keep track of those things. I won't keep coming back to that because I want to use our time a little more efficiently, but I just keep pointing that out to you. Now, do you guys have any questions on any of that or on any of the stats that you're learning, right? Just point you to this while you're, this is in the, well, if you go to home and you go to the complete online module, you'll see this online instruction module here. You'll see example videos that I'm putting up. These are things that I've created, including the PowerPoint slides with lecture. And then these recorded lectures are under the recorded tutorial sessions. Okay, so I'm open to questions if you have them. If not, then we'll explore some ideas from 6.3. Okay, then I'm going to switch this over here. And it is my hope that you are now seeing my OneNote, where I usually write notes. And we're going to take a look at 6.3 sampling distributions. Now, I've laid a lot of the groundwork for this section in some previous in those previous videos. All right. So I won't be talking about a lot of the groundwork right here. I just want to get into some examples and show you some of the stuff that we're doing. Okay, and this in conjunction with you going back and looking at the lectures, hopefully will all kind of come together. So here's what we're going to do. I want you to consider a very, very small population. Okay, and when I say small, I mean small. And you guys should be seeing my screen and hearing me okay. Will you just give me some pluses in chat if you're seeing my screen and hearing me okay? Okay, thank you. All right, so here's our population. Just 3 numbers, okay? No big deal. That's our population. That is the entirety of the population. So we know a couple things about that population right away, right? Let's see. We know, for instance, that the average of that population is 6. So mu equals 6. Okay? I'm going to throw this in my calculator and get all of this we know that the average is 6, okay? And standard deviation is 2.16. Okay. Now, those are things we normally don't know about a population, but because we know the population, 4, 5, 9, then we know those things. But we're going to kind of just go through this practice. What we're looking at in this particular section is we're looking at, make sure I started this recording. Yeah, okay. So what we're doing is we're looking at the idea of sampling, right? Because we know in statistics that's what we do. We sample from a population. And so we need to know a little bit more about how the statistics we get from our sample behave, right? Because we're basing all of our things on the statistics from our sample. All of our decisions and all of our answers to questions come from the sample statistics. So we need to study those a little bit more, and that's what we mean when we talk about sampling distribution. So here's how it's going to work. We're going to take samples of size 2. Okay? Size n equals 2 from this population of size 3. So again, we're really simplifying this. Normally our population has thousands and thousands of members in it, and we're taking bigger samples, say size 100. But there's no way we're going to be able to do that by hand, so we're shrinking things down. All right? So let's take a sample of size 2. So for instance, maybe we get 4, 5. And we're doing this with replacement, I should say. So we could get 4, 4. All right? And there's a sample. So what do we know about that sample? We know that its mean, x bar, is 4. Right? Okay. Good enough. Let's find another sample, maybe of size 2. 4, 5, we could get 4, 5. The mean there is 4.5. Right? So maybe like one day we found a sample of size, or we took a sample of size 2 and we got the 4, 4, right? And then the next day we came along and took another sample and we got a 4, 5, right? And each day we calculated the mean of that sample, and it turned out the mean was 4 in the first case and 4.5 in the second case. Well, if we continue this, the next day take another sample. Maybe we get 4, 9, right? And the mean there is 6.5, right? And we do it again, we get, say, 5, 4. The mean there is 4.5. And then 5, 5. The mean there is, of course, 5. And then 5, 9 is another sample we get it on another day. The mean there is 7. We'll keep going. 9, 4. The mean there is 6.5. 9, 5. The mean there is 7 again. And 9, 9. And the mean there is 9. So look, those are all of the possible samples of size 2, right? Okay. Let me type this in here. We'll get this going. Okay. Now, what the interesting thing is what we're really interested in studying when we study sample distribution. Is the actual samples that we get, the actual means from the samples we get, right? And so we could look at those and we could see these are all of the possible means that we can get when we're taking a sample of size 2. Okay, so I see, yeah. Sorry, Candace, I just saw you saying, let's talk at the end, Candace. about that? Yeah, okay, so real quickly on the Top Hat question, we are done using Top Hat for attendance. We just can't do it, right? So all I'm doing with Top Hat is sending out the slides. We really had to pare back, given the circumstances. So, okay, so these are all the samples, right? These are all the sample means, right? And so we could actually create a little chart of these things. Right? We could say, okay, what for the sample mean, you could get a 4, or you could get a 4.5, 5, or a 6.5, a 7, or a 9. I think I've got them all listed there. And what's the frequency of those? Well, 4 shows up once, 4.5 shows up twice, 6.5 shows up twice. No, sorry, 5. 5 shows up once. 6.5 shows up twice. 7 shows up twice. 1 shows up 9 times. Is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And so this is called a sampling distribution. And if we put it in graph form, right? We have bars that kind of look like this. Oops. It just goes up 1. 1. Our first bar goes up 1, and then this bar goes up 2, and then 5 goes up 1, and then we actually have 0 from there, so I need a little more room there. But then this 6.5 goes up 2, and 7 goes up 2, and 9 goes up 1. Right? So there's our distribution. We can kind of look at the shape of it. Right? And that's our distribution. That's the distribution of all of the samples of size 2 from this particular population. So when we talk about sampling distributions, that's what we're talking about. It's imagining that you can take all of the samples possible, right? And when we're talking like 100, samples of size 100 out of 40,000, there are a lot of samples. But if you take all of the samples possible of size 100 and find all of their means, and then graph just the means, you're going to get the sampling distribution. All right. Now, so what we've got here is kind of this is the if we label this is kind of the I'm just going to label it like this. This is the graph of the sample means. Okay, that's the graph of the sample means. So that's what we mean when we talk about a sampling distribution. All right. Okay. So I talked for a little while. Do you have any questions on that? Is there anything you want to ask about that on that? Okay. I'm gonna keep going because we want to just kind of keep moving here. So let's do this. All right, so let's look at another situation. So let's consider this population. All right, so the population, we'll work with 4 numbers here. Let us do, what does the F mean? Frequency. The frequency. Whoever just popped in, will you mute your mic? Talisha? Talisha, can you mute your mic? Thank you. I mean, unless you have a question, that's just fine. But all right, so let's look at this one here. Here is our population. These 4 numbers. Okay? And they actually represent the amount of caffeine in either a Coke Zero, a Diet Pepsi, a Dr. Pepper, or a Mellow Yellow. All right? And so we're going to take samples of size 2. And we just want to study these samples. Okay, so we're going to take these samples, and then we're going to find the mean of each sample. All right? So now, we're going to do this without replace, or with replacement. We're going to do it with replacement. So we kind of have the same thing. 34, maybe one time we sample and we get a 34, 34 for a mean of 34. All right? Then maybe we get a 34, 36. Oops, 34, 36. And I think the mean there is going to be 35, right? If we find the mean of those two numbers, it's going to be 35. 34, 41, 75, so 37.5. Yes, and then a 3451, right? So that's another possible sample of size 2. And there's 85, so 42. Right? So that's the mean of those, all right? So we're going to kind of keep going here. So it's going to look, let me just write for a little while, 36, 34, mean of 35. 36, 36, that's another sample. Obviously the mean there is 36, 36, and 41. And the mean there is what? 77, so 33.5. Sorry, 77, 38.5. Better. 36, 51, 87, 43.5. All right, and we keep going. 41, 34, 41, 36, 41, 41, 41, 51, and then we go 51, 34, 51, 36, 51, 41, 51, 51. So we need the sample, the mean from each of these. So we'll start there. 51 and 41 is 92. 87. So that's 43.5. 85. Right? 85. So 42.5. 92. So 46. 41. 77. And that's going to be 38.5. Okay, so long process, right? And we're just dealing with samples of size 4. But those are all of the possible samples. So if we were doing a study on this sample, on this population, and just sampling 2 at a time, we might get any one of these outcomes, right? So if we created the graph of these outcomes, okay, let's create our little frequency distribution first. So we could have, let's see, we got 34, 35, 36, 37.5, 38.5, 41, 42.5, 43.5, 46, and 51. Now, we could have missed something there, but we'll see how it works. So there's 134 in this. There it is, right? How many 35s are there? Two 35s. How many 36s are there? I'm seeing just a single 36. 37.5, so I'm seeing two of those. 38.5, two of those. 41s, one. 42.5, two. 43.5, two. 46 is one. No. 46 is going to show up another time twice. 51 ones. So there should be 16, 6, 13, 10, 11, 12, 14, 15, 16. Hey, we got it. Right? And so the distribution, I'm not going to draw it. I'm going to let you imagine it, right? I mean, here's 34, 35, 36, right? I mean, you can kind of see it. It's just this thing sideways, right? You would have a dot, one dot at 34, two dots at 35, one dot at 36, two dots at 37.5. It's going to look like that. We'll do a dot plot there. And that continues. Okay, but you can imagine it easily from this thing, right? Okay, so that is our sampling distribution. And the goal then is to understand totally how these behave. Now, here's the interesting thing. What does the population mean? Population mean. Well, so we're gonna find the mean of these four numbers. That's our population, right? And so throw that into our good trusty calculator. And we get 34, 36, 41, 51. And so the mean there is 40.1. So mu equals 40.5, sorry. 40.5. All right. Now, so what's the mean of the population? Now, what is the mean of the sampling distribution of the sample mean? So that's the question. That's actually the question. What is the mean of the sampling distribution of the sampling mean? What they're saying is, now find the mean of all of these. So that's what we mean. The mean of the sampling distribution is the mean of all of the means. All right, so I want to find the mean of all of those, so I'm going to quickly as I can, enter 16 numbers. I'm going to enter all of those into my calculator. So 34, 35. I should have been having somebody do this as we went along. I need to refine my online teaching tactics next time. Okay. Let me just double check. 34, 35, 37. So this makes riveting TV. Okay, got it. All right, so we go in there. We're going to calculate our. So the mean of the sampling distribution. So the mean of the means, which I'm going to write like this. I'm going to make it big so you see. The mean of the means. That's what I'm talking about. That's the mean of the means. Or if you want to use the official language, it's the mean of the sampling distribution of sample means. Right? I like mean of the means because I can see that I'm just taking the average of those numbers, those averages. Well, look what it equals, 40.5. Bam. The mean of the population is the mean of the sampling distribution. Okay. So that tells me a really important thing. The average, if I want to find the average of the averages, if I'm doing all this work with the averages, I know what the mean is. The mean is the mean of the population, right? And so that's a powerful thing that we'll see. Now, I'm going to point you to the other two lectures, or the other two, let me do it this way. The other two things that I've created for this section that I think lay the groundwork for this idea. And you should be seeing my screen right now, just my generic. Just give me a plus in chat if you're seeing just my Canvas page here. But I want to show you this right here. So this is where you need to go. This is where I lay the groundwork for this idea and give you the important results. Let me caution you about this for a second real quick. This particular section is kind of theoretical and kind of, I don't know, it's kind of out there a little bit. We're going to take the results from this section and we'll boil them down to something that we'll use, I think, more directly. So if it feels a little, ephemeral here, this idea from 6.3, don't panic. Just do your best with it, and then we're going to take the ideas from this and they become more usable and practical. So it's a little bit different. But here's what we're going to do. I want you to go to the complete online module when we get done here. And what you're looking for are these, by the way, this thing that we've done today will be in this recorded tutorial session once I get it converted. But if you go to the example videos, you will see a few things created for section 6.3. And that's my plan for each of our sections moving forward. I'll get 6.4 up later today because you need to make sure you're starting on that. But if you'll watch this intro to sampling distribution, part 1, and then there's a part 2 as well, it'll kind of give you some visualizations for what it is we're trying to do with these sampling distributions. Because what we're really interested in is understanding how sample means work. Okay? And understanding, because we work with sample means. We also work with sample proportions, and that's what these ideas are about, is telling us how these sample proportions and sample means behave. A couple things that you're going to see in these videos. Sample means, whether they come from a population that is normal or not, sample means are normal. They are normally distributed. You didn't really see that with the examples we did because they were so small. But when you create sample means for real populations, right? Like, so for instance, if you're studying average IQ and you go out and survey 100 people and you find their average, and then you do it again and find another average, and you do it again and find another average. If you then try to create a distribution like we did here on the screen, you're going to get a graph that is normal. So that means that averages, sample averages, are normal. Okay. The other thing about sample averages is they are what we call unbiased estimators. All right, which means they are good. It's okay to use sample means to estimate populations, which is good because that's what we want to do. That's also true for proportions. They are normal, and they are good unbiased estimators. We can use sample proportions to estimate population proportions. All right, so you'll see all of that kind of outlined and discussed in those videos. Now, remember, there are full lectures on these in Canvas, right? So, or in MyStatLab. I'll just remind you where to go to get full lectures. You go to MyStatLab. You go to Multimedia Library. And in Multimedia Library, you want to select Section Video Lectures and find those. And you can see that down here in Chapter 6, Sampling Distributions and Estimators, there's a lecture, right? So you have several sources for this material. Okay. That being said, the purpose of what we're doing here today, the purpose of meeting at 1:30 on Mondays and Wednesdays, is to answer your questions. So as you go through sections, and right now we are, where are we at? We should, we've had several sections online now, right? 6.2, 6.3. As you go through those sections and go through the homework, you will write down your questions. Bring them to this session, and we'll answer them. Now, we only meet twice in a week, so that means for those two, well, no, we're good. We meet twice a week. That's what we met for before. All my other classes were before. So, but bring your questions and have them ready to go at the beginning. We won't every time have to, give this introduction and reminder. We'll just jump right into questions. And it's my goal we can answer dozens of questions. Well, maybe not dozens, but hopefully, a good dozen or 2 dozen, so that I can help you. Because I know that a lot of you, working from home, you don't have access to the same resources you had before. And so that's why we're meeting now. I don't want to spend it doing a lot of lecturing. If you don't have questions, I'll lecture. But anyway, bring questions. So with that said, we've got just a few minutes. Is there anything you want to ask about now? Any questions? You can unmute your mic and you can speak to me. Okay, let's talk about this while you're thinking of questions, because, I've extended the due dates for the assignments. If you look, they have been extended greatly. Now, you have, sorry, turn that noise off. You have, if you look at the deadlines, so see, I've extended the deadlines already, but the Chapter 4 and 5 test is something, well, you know what, let's do this. Let's extend the 4 and 5 test a little bit more, just because we're still getting rolling, but you've got to catch up with these other things because they will start catching you, all right? So I'm gonna go ahead and put that deadline till Friday for the 4 and 5 test. But I'm not going to change any of the other deadlines. They've already been extended quite a bit. So follow those deadlines in Canvas, or not in Canvas, in MyStatLab. But this test you got to get done and get out of the way because we are moving on to Chapter 6, and we're going to have a Chapter 6 test here before you know it. Right? I don't know. Friday at some time. It's Friday. It's the 27th. Whatever. Usually they're at midnight, right? So Friday at midnight. Well, let's see. Other assignments that we've got due. We don't have. The only assignment that was due. Everything else was back when we were meeting together. The next assignment is 6.1, and that's due on Wednesday. Will that work all right, Christina? That's your first thing that is due, and that's on Wednesday in this online section. All of the MyStatLab due dates are by midnight, even the tests. Okay. But I think that's the first one, and then you have those tests and things on Friday. Okay, let me mention this again. If you have questions, throw them up. You should still be seeing my screen because I want you to see this. If you go to Canvas, right now, USU has online tutoring that they have put together specifically for this online, craziness that we're all involved in. if you click on that, you should see, it'll take you to the page that lists the courses. Now, you'll not see Stat 1045, but Stat 1040 is the same thing. Okay, so that is available. Let me just see. Do they have? Well, they give some times here, right? And they give lots and lots of times, right? And so you just click on that, and it basically takes you into a WebEx room like this. So you're already in WebEx now, so you'll have a real similar experience here. I don't know what'll happen. I just jumped on it. We'll see. We might freak out the tutor. Yeah, you can take the test anytime, just like always. You can take it any time up until that deadline, but the tests are all take-home, so you just take them at your own home using your books and your notes. You can use books and notes. You can use your calculator. You can't use other people. Okay. So we're going to see. We're going to jump in and see this tutor, see if how this tutoring is going. Now, this is for all students, so you may jump in here and you might have to wait for a little bit because this tutor is trying to juggle between several students. But yeah, so they have to admit us, and that's okay. But just be patient. It's an option there, so that is available. And if I get more information about other tutors that are available, they're there. Or I'll pass that on. I'm not gonna stay in this one. But that link is available right there on the home Canvas page, USU Online. All right. So that's my suggestion. I think Candace was asking about that earlier. Work them to death because they are available. It'll take some patience, but there's an option for getting help. You can send me messages in Canvas. You can ask questions during this time in Canvas. I really don't want this to be a lecture because it's just not a great format for lecturing when we don't have, when we can't talk a lot back and forth. I'll use it for lecture if we don't have questions, but I would much rather ask questions. But that means you've got to bring questions ready to ask, right, so we can roll. Okay, can you think of anything else? We've kind of hit our time for today, but can you think of anything else you want to ask today? Yeah, on the test, yes, you can take it up till 11:59, but you have to be done by 11:59. Remember that, right? Because it will cut you off at 11:59. You can't start at 11:58. All right, guys, listen, I know this is difficult, but, I'm committed to help you through this. But that means you might have to start sending me messages in Canvas, asking questions in Canvas, asking questions here. And yeah, you're going to be doing a lot of learning on your own as you watch those lectures, that are already posted. Do your best on that. I will help you as much as you can. Use other resources, establish other things that you can as places to get help. But, there's no reason we can't make this still a successful, if not crazy, semester. So anyway, you guys have a great day. Be safe. Check those due dates in my lab and watch for material from 6.4 because that's also, you're supposed to start that today. So we'll see you next time. We'll see you on Wednesday. Have a great day.